Welcome to Penrose Learning, where we make understanding easy.
You begin by securing the essentials: a stable 720p or 1080p camera mounted at face height and consistent lighting. Once ready, create a Python 3.8+ virtual environment and pip install OpenCV, dlib, and face recognition so you have the libraries to detect and encode faces. Now collect labeled samples. Aim for 20 to 50 images per person with slight pose and expression variation. Make sure to organize them in named folders. This naming becomes the identity label in your attendance database. Once your dataset is structured, run face detection on every image, align and crop faces so the input is consistent, and apply simple normalization like histogram equalization to reduce lighting variance. Next, compute 128-dimensional embeddings for each face and save them with the person ID in a CSV or SQLite table. These vectors are your learned signatures. Then train a lightweight classifier such as k-nearest neighbors or SVM, or use direct distance thresholding. Make sure to validate performance with a holdout set and adjust the threshold accordingly. You finalize by implementing a real-time loop. Grab each frame, detect faces, compute embeddings, and match against saved vectors. When a match exceeds your confidence threshold, log attendance with a timestamp. Then integrate a simple UI and database that shows name, confidence percentage, and a snapshot, and allow CSV export or server sync. Finally, harden privacy by hashing identifiers and securing the DB. If matching fails, first check camera exposure and lighting. Retrain with more varied samples if false negatives persist.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.